Greetings. In our previous video, we talked about how data is the fuel for artificial intelligence and how this massive brain is fed, but today, we are entering the refinery process where the real craftsmanship begins. Data preprocessing in the world of AI. Your raw data isn't a priceless gem at the start. It's just a muddy, shapeless piece of rock if you throw this rock into the machine as it is. The machine won't see the jewel inside. It will only process the mud today. We're setting aside complex lines of code to talk about how to wash away this mud, how to trim the diamond, and how to give it its final shine. If you're ready, let's step into the magical world of data, which transforms raw data into a workable treasure. Our first problem in the kitchen is the deep cracks and missing pieces on the diamond. In other words, the missing values in our data set. Imagine a survey where half the people didn't write their age, or the square footage of a house was never entered. There are two ways we can handle these gaps. The first is the deletion method. If your dataset is very large and that missing piece isn't critical, you simply toss that row into the trash. However, if the data is precious, we use the imputation method. We fill the gap with a filler that matches the surrounding texture for numerical data. We usually take the average mean of that column and write it into the void. This way, we preserve the integrity of the diamond and prevent the model from making mistakes. Next up are those unnatural, jagged protrusions that ruin the diamond's form. Outliers. Imagine you are collecting house prices in a neighborhood. Most houses are between $3 and $5 million, but suddenly, a $500 million mansion, or an erroneous entry, slips into the data. This single outlier destroys the AI's entire perception of that neighborhood. The model starts producing wrong predictions because it thinks the average is much higher than it actually is. This is why we detect these sharp edges and either trim them down or gently remove them from the dataset. Having a balanced and smooth diamond ensures your algorithm works much more stable. Now we are at the stage of cutting and defining the diamond. Computers cannot perceive colors, cities, or names like we do. They only speak the language of numbers. If you tell a computer the color of this diamond is sapphire blue, it can't plug that into a calculation. This is where encoding comes in with label encoding. We give each color a number, like calling blue 1 and red 2, but beware. The computer might think 2 is greater than 1 and assume red is superior to blue. To prevent this, we use one-hot encoding. We create a separate column for each color and write 1 if that color exists and 0 if it doesn't. This mathematically explains to the computer that there is no hierarchy between categories and that every piece of data is equal. Polishing or scaling your dataset might contain very different scales. For example, on one hand, you have income data in the millions, and on the other, you have number of rooms ranging only between 1 and 5. AI might see those huge numbers and think they are much more important, ignoring the smaller but crucial details like the room count. By using standard scaler, we put all these different values on the same scale. We rescale every piece of data so that the mean is 0 and the standard deviation is 1. Now, neither the $1 million income nor the single-digit room count overpowers the other. Every facet shines equally, and our model evaluates every detail with equal accuracy. Sometimes, cleaning the mud and trimming the edges isn't enough to make a diamond truly breathe and capture the light. You need to cut new facets into it. This is what we call feature engineering. It's the art of creating new, more meaningful information from your existing data. For example, if you have a date of birth column, the AI might struggle to find a pattern, but if you transform that into age, you've just cut a new facet that allows the model to see the data much more clearly. Remember, your model is only as smart as the features you provide. By engineering new perspectives, you turn a simple stone into a masterpiece. In the world of diamonds, weight is important, but unnecessary weight is just a burden. Feature selection is the process of deciding which parts of your data actually add value and which are just noise. If you are trying to predict the price of a house, knowing the customer ID or the owner's surname won't help the AI. It will only distract it. A true specialist knows that less is often more. By removing these irrelevant features, you make your model lighter, faster, and much more accurate. We don't want a heavy rock. We want a pure, concentrated gem. Our diamond is now polished, engineered, and trimmed. But before we take it to the market, we need a reality test. This is where we perform the train test split. We take our processed data and split it into two. The training set is the textbook we give to the AI to learn from. But here is the secret. We hide a small portion of the test set and never show it to the AI during its education. Why? Because we want to see if the AI has truly learned the patterns of a diamond, or if it has simply memorized the specific rock we gave it. If it can accurately value the test set it has never seen before, then congratulations, you have a model that is ready for the real world. Today, we didn't just clean data. We performed surgery on it. From filling the gaps in encoding categories to engineering new facets in the final reality test, we have transformed raw material into a digital jewel. The data preprocessing stage is where the battle is won or lost. Now that our diamond is flawless, we are finally ready for the most exciting part, the model training stage. In our next video, we will put this diamond into the machine and see it shine.